This time I'll be recording on my iPad, so see how it goes. These notes are titled Finding Rational Roots. So, finding rational roots. The first thing that I want you guys to do is glue in something, so let me put it in here. Okay. So let's title this actually. Rational root theorem. I'm going to put this in green. You guys will just have to know what it means. You don't have to memorize it or anything. So this is what it is. Suppose that a polynomial equation with integral coefficients has the root h over k, where h and k are relatively prime integers. All that means is that it's reduced. That's what that means. Then h must be a factor of the constant term of the polynomial, and k must be a factor of the coefficient of the highest degree term of the polynomial. First will come the example, then the explanation, because it's kind of weird to explain without an example. So first example, whoops. So example first. Then explanation. So I'm going to be just showing you what this theorem means so that you can use it. So the example, direction here, example. We'll have directions like this. List the possible rational roots. List the possible rational roots. And then they'll give you an equation, and our polynomial equation will be 6x to the third plus 8x squared minus 7x minus 3 equals 0. And what I want to do is color this in pink, actually, and then the 6 in blue. And you'll see why in a moment. The next thing I'm going to do is find the factors of each of these things that I colored. So first thing will be factors of -3. Factors of -3. And I'm going to write those down. This is part of the process. So I'm going to write down the factors of -3. That's this term at the very end there, that constant term. So factors of -3, that would be plus or minus 1. All these factors are going to have a plus and minus in front of it because you can do any combination of plus and minus to get whatever factor you want. Almost picked my nose, but I didn't. That's awkward. So plus or minus 1, that's always going to be a factor for our problems here. And 3 is a prime number, so plus or minus 3. And those are our factors of the constant term. And this will be pink. And then below that, next I'm going to write down the factors of the coefficient of the term that has highest degree, and that would be the 6. So here I will write factors of 6, and again it'll be plus or minus 1, plus or minus 2, because 2 times 3, plus or minus 3, and plus or minus 6. Those are all of the factors. And that's in blue. I'm going to underline that in blue so that you can see where it came from. For later reference, this will be the numerator. The numerator. Numerator. This will be the denominator. Denominator. And I'm going to circle these in green. You'll have to remember which goes where. The constant term factors will be the numerator. The factors of the highest degree term coefficient will be the denominator. And then I'm going to use these to list my possible roots. So I'm going to use these factors of -3 and 6 to list my possible roots. So here I'll have my list of possible rational. These aren't just any roots, they're the rational roots. They won't include, say if root 2 is a root, this procedure won't include that. We won't know. So here it's just rational roots. That's what we're looking at. And what we're trying to do now is taking all, whoops, that's cool, I can move that, huh? What we're doing now is taking all combinations of this and that together in a fraction. And those will be our possible rational roots. Some of them won't be, maybe some of them will be, but those are the candidates. Those are the ones that we can check in our polynomial to see if it is or isn't. Otherwise we'd have to check an infinite number of roots, and we can't do that. So the possible rational roots, well, the first numerator is plus or minus 1, so I'm going to write that down. First numerator is plus or minus 1, plus or minus 1. And then my denominators are just all listed there, factors of 6. So plus or minus 1, that can be one of the denominators. And then I just go through them all. Numerator is the same. Then a 2, plus or minus, oops, 1 over 3, or plus or minus 1 over 6. And we could keep going. Because now we're going to look at our second numerator and then just try out all of those things. So we'll have plus or minus 3 over 1. I'll do it down here. Plus or minus 3 over 2. And then plus or minus 3 over 3. Oh, that's a repeat. This is the same thing as this. So what I'm going to do is just cross that out just so I know that I don't need it. Don't need to check that one again if I was to check these. And then plus or minus 3 over 6. And again, I don't need this because this is the same as 1/2. And I already have 1/2 right there. Okay, so these are the possible rational roots. That's all that the theorem says. If you have a polynomial, you take the factors of the constant term, which here was the 3. You take the factors of the constant term and take all possible combinations when you divide that by the factors of the highest degree term. And in this case, the highest degree was 3, so we took the 6. And you're just taking the fractions, plus or minus always. And these are our possible roots. So this is our answer, actually, because the question, or the instructions said, list all possible roots. List the possible rational roots. not all roots, but just the rational ones. That's what this theorem tells us. So let me write down the steps. Let's see here. Step 1 in blue. So the first thing that we did was list factors of the constant term In our case, that was the 3 in pink. Second step was to list the factors of the coefficients. List the factors of the coefficient of the highest degree term. Just look at the highest degree term, get the coefficient, write down its factors. So list factors of the coefficient. List factors of the coefficient of the highest degree term. And then the last thing, step 3, is to make a list of possible rational roots by taking that constant factors as a numerator and the coefficient of the highest degree term as the denominator in all possible combinations. So list by, I'm just going to shorten it up, list by making fractions. List by making fractions. So this was example, shoot, I forgot, 16. I didn't forget. And that's how you use the rational roots theorem. So next example, let's see here.